Morning, students. We started the chapter probability, and in the first exercise, we saw conditional probability. Again, we will look the conditional probability with the formula. Will start and new things, multiplication law. We will see. Look at first. What is conditional probability? I taught you. Suppose I write here B upon A. And if I simply ask you what is P of B upon A, you know it, I think. P of A upon B, we read it. It's a P of B upon A, which means P of B intersection A upon P of A. That formula already we've seen it. Now what new things we are looking for? We do transfer P of A here this side. What we are having? P of B intersection A is equal to P of A. I multiply, cross multiply, I'm having this one. So can I write B intersection A also can be written A intersection B, which means P of A into P of B upon A. Now this is very important formula, you have seen it. Initially it looks tough, but it is not so. You have to try to understand the meaning of that. P of A intersection B, try to understand it with a language. A and B intersection always follow and. A and B in the sense when two events are happening or occurring one by one, consecutively or continuously, two events are occurring. First A occurred, then B is occurring. So when two events are occurring one by one consecutively, that will called A intersection B. And this means P of A into this formula we got actually, P of A into P of B upon A. Now you have to understand that when A and B here are not independent, very important thing. Why I am writing this thing, I tell you. What is the meaning of P of A intersection B? A and B. And the formula is P of A, meaning probability of occurrences of A, then P of B upon A. Upon A, you don't confuse about that. That A says probability of B, but which depends on A, or after occurring A, what is the probability of B? Now already we have seen the meaning of that. So this time you have to be careful about the language, that P of A into, it is actually P of B, but after occurring A, it depends on A. After happening to A, what is the probability of B? That is given by P of B upon A. By words, it seems very tough. But when you look the example, I will tell you that it's gonna so easy. Look at, I tell you, when A and B are not independent, it means that B depends on A actually. B depends on A actually. So that it is told P of B upon A, P of B, probability of B after occurrences of A, meaning A has been occurred, B depends on A, and then probability of B we need to find out. I can give you example, don't worry about that. A and B are not independent, very important they are written. Okay, let me speak something about one question. One example I want to definitely show you. First, let me tell you what is independent event. I have 52 cards. If my friend draw a card from 52 card, he looks it and observe, and again he replace the card. Again he replace the card. Look at. Again he replace the card. Then I shuffle and I again offer to my friend to draw that card, draw a card. Definitely when second time he or she will draw the card, these two events are independent. Why? Because first time what he drew the card, second time the same card may be drawn, because card was replaced. When card is not replaced, that time it is called not independent. But when card is replaced, this is a very important word, when card is replaced, again total number of cards will be 52. After shuffling, when second time a card will be drawn, the card will be same as first card was drawn. So you know, this time the second occurrences or second event is totally independent from first one, because number of cards are same. The cards actually was replaced. But in the case when cards are not replaced, suppose I have 52 cards, my friend draw a card and keep it aside, definitely number of cards now it is 51. So second card, when it will be drawn, it is depending on first one, because first card cannot come that time only, because it already have been drawn and it kept aside. It kept aside. So definitely when second card will be drawn from 51 card, so that second event will be depend on the first one. So this is only the thing which I want to tell you. Now look at here, it is not independent. We cannot say it is depend, but we'll say it is not independent. So this formula will apply only when the events are not independent, meaning that time the cards will not be replaced. Okay, let me speak something. Suppose I write here one by one, two cards without replacement are drawn. Find the probability that first card is an ace card and second card is king card. Very simple question I have taken here, but meaningful question it was. Look at one by one, two cards without replacement. That is very important thing which actually indicate towards the formula, that this formula is applicable when they are not independent, and definitely when it is without replacement, meaning the events are not independent. First card is drawn, kept aside, second card is drawn, it is now two events are not independent. So okay, now question says find the probability that first card is an ace card and second card is a king card. So first drawn card is ace card, we will assume it is event A. Second drawn card is a king card, it is assumed as a second event B. So I'll write here something that let A is event of the first card is an ace card and B is an event of a king card. That's simple. So definitely two cards are drawn one by one without replacement. What to find out? We need to find, very short I'm doing. First card is an ace card and second card is a king card without replacement. We will use this formula. So what the formula is? First A will occur without any condition, but B will occur depends on A. Very simple thing it is now. Now try to understand. First event will occur independently. First card will be drawn independently. But second card will be drawn. What will be drawn actually depends on first one, because first card already have been drawn. It has kept aside, and definitely when second event will occur, it will depend on first. Second event will occur, it will depend on first. That is very simple symmetry. Try to hear the lecture twice and thrice, you will get the meaning. I am actually trying from my side well best, but you just do try for understand it. Okay, so P of A into P of B upon A, what is its meaning? P of A, probability of A. A is ace card. So what is the probability of ace card? Number of ace card 4, number of total card 52. That you have done it. But what about probability of B upon A? You don't worry about upon A. It is not divided. It indicates that probability of second event actually depend on first one. And why not it is? Because the card was not replaced. Second event is a king card. So how many kings in a shuffle, deck of 52 card? Definitely we know the number of kings are 4. So this time the 4 upon number of cards, and that is important, number of cards will be remaining 51, because first card was drawn and it was not without replacement, it was not replaced. So number of cards remaining in deck is 52. And definitely 51. So number of cards will be 51. So it is whatever the answer we will get, it is the answer P of A intersection B. That is actually very interesting concept. This is actually called a multiplication law also. P of A into P of B upon A, where A and B are not independent. A depends on B, and that is simple formula will apply here. That first event, then second event occur one by one, one follow the other. Definitely its formula will be easy to you. So this is the concept which I wanted to share with you. Please write this formula. Now one more thing I want to write, and question I will exceed it. Look at Suppose the question asked here 3 events, suppose it is. Very interesting it is. Suppose 3 events are occurring one by one. Same thing, one by one. Instead of 2, suppose 3 cards are drawn without replacement. Look at without replacement. Then what is the probability that first card is an ace card, second card is a king card, and third card is a queen card? Suppose this question has come. Now one can understand. Same symmetry, same methodology, same action will be taken here. 3 events one by one are occurring here and they are not independent. The formula what will apply? First, P of A will, meaning A will happen, A will occur independently, but B will depend on A. Definitely second event is depend on A, and here third event will become, but it depends on previous A and B. This is only the symbolic formula. But let me tell you that when you will operate the formula on the question, it actually not effective very much. One should understand only P of A will happen. P of B depends on A. P of C depends on previous both. So I think it's nothing worry. Now look at, I tell you, I can give the answer. Suppose the same question we have, and suppose C is the event in a queen card. Now you can simply tell that P of A. What is the meaning of P of A? An ace card. So A's number of is 4, 52. Now you understand. P of B occurring. So then probability of the second event occur. It's a king card, but number of card now 51. P of C, again queen card occurring. It's a 4 cards a queen card, you know that. But in upon we have 50 cards. One can understand that B is depend on A, that's why it came 51. C depends on previous both, that's why it came 50. And that is your answer, whatever the answer will have. So I don't think it's a trouble, students, very easy. Before it, I taught you for 2 events, it is for 3 events. And suppose 4 events we have, we can increase it, no worry about that. Okay, so hope you have understood till here what I am just trying my level best to teach you there. Look at now, the next is. Now I'm telling you some very important thing, that if A and B are independent event, very important I'm telling you, this time events are independent. Previous formula I taught you, which was actually not independent. I tell you one thing, that P of A intersection B, we know P of A intersection B is equal to P of A into P of B upon A, you know it. But if you focus on this formula, A happens independently and B actually happens depend on A. But this time A and B are independent. Suppose I have 52 card. My friend draw 1 card from 52 and replace it. Definitely again having 52 card. In second time, if she or he will draw 1 card, the second event is not independent on first, depend on first one, because card again 52, independently he or she can draw 1 more cards. It means that after replacing the card, both events will be independent. So replacement word is very important. Whenever the cards are replaced, definitely events will be independent. When the events are independent, no meaning of P of B upon A, because second will not depend on A. I tell you one thing, that when A and B are actually independent, P of B upon A is nonsense. Actually it is P of B. You can understand that B will not depend on A. So what is the meaning of upon A? Because upon A was symbol that it depends on B. But that time B is independent. It is not depend on A. So P of B upon A will be simply called P of B, because it doesn't depend on A. So I would speak something about the formula, students. P of A intersection B will be P of A into P of B only, no B upon A, and that is phenomenal formula. We have done it. We have done a good job here. That P of A into P of B. This is a very simple formula we have got when A and B are independent event. Already we have written here independent event. So this is the formula we have got it. Whenever in the question you may be told prove that A and B are independent. What you will show? You will show P of A intersection B is equal to P of A into P of B. If one can show this one, it means A and B are independent event. So one can also go with three formulas, three events. Suppose A intersection B intersection C we have. So when A, B and C are independent event, independent P of A into P of B into P of C. Now you can understand it. It's no matter about P of B upon A or C upon A intersection B, because this time all events are independent. So very good formula we have got here. Now I will tell you some example from the book which depends on both the things. Look at them one by one and try to understand, and we can make difference between these two formulas. How we can they be applied on the questions. Look at. I have example number 8. Question says, an urn contains 10 black balls, 5 white balls. 2 balls are drawn from urn after one after the other, meaning one by one, without replacement. Try to understand. Without replacement has come the word. It means that events are not independent. What is the probability that both drawn balls are black? Well, it's very easy. Look at. First I tell you, number of black ball, it's a 10, and number of white balls, it's a 5. I would say total balls 15, and let event I consider in 2 balls are drawn without replacement. Question says both drawn balls are black. Okay. Event first drawn ball is black. Second drawn ball is black. Why? Because both drawn balls are black. We have to find the probability. So one can understand what to find out. We need to find first drawn ball is a black and second drawn ball is a black. So we know what you know. P of A intersection B is equal to P of A into P of B upon A. Why I am writing upon A? This time A and B are not independent here. Events are not independent. So I'll write the answer only. P of A intersection B is equal to P of A. What is the meaning of A? A meaning black balls. So how many black balls are there? 10. So 10 upon total balls of 15. P of B. What is the meaning of B? Second ball is a black. So black ball. Now very interesting thing. Black ball. This time it was 10. But 1 is already drawn now. So how many black balls are remaining now? 9. And upon 14, because 1 black ball is drawn and it was not replaced, number of total balls will be 14. Number of black balls will be 9. So second event have a 9 by 14. So whatever the answer, 5 2s are 5 3s are 3 3s are and 6 2 7s are, and whatever the cancellation will have, this is your simple answer. They got it. Hope you have understand it, that what I am doing here. Two things will concern, that whether events are independent or not. Definitely it depends. You know that the both formulas what we read depends on these conditions. Okay. Now we have a question. Example number 9. I'll show here. Example number 9. What question says? 3 cards are drawn successively without replacement. Again, focus, without replacement has come, and 3 cards there. From a pack of 52 cards, what is the probability that first 2 cards are king card and the third is a ace card? Very simple. Total cards 52. Let A is first drawn card is I think king it was. First 2 cards are king card. So first drawn is king. B is second drawn card is again king because first 2 cards are king. C is third drawn card is an ace card. Now what to find out? We need to find first card should be king, second card should be king, third card should be ace card. Here, according to question, A, B, C are not independent because cards are not replaced. Look at it, it's specially stated here without replacement. So we know what you know. You know it? P of A intersection B intersection C is equal to P of A into P of B upon A into P of C upon A intersection B. This is only the formula, looks tough, but it is not so. Very easy thing it is. What is the meaning of P of A? A meaning first drawn card is a king. How many king there are? 4. 4 by 52. What about the second? P of B upon A. What is the B? Second card is a king card. Now one can understand without replacement number of cards will be 51. King was 4. One already have drawn. So number of cards now remaining 3. So 3 by 51. And ace card. C is an ace card. So number of ace cards are 4. But remaining cards are 50. So whatever the answer you will get, this is gonna be your final answer. I don't want to solve till end because question almost has come. You can do it further. So hope you have got the condition. What I wish to tell you. Now look at the next one. Question says now, example number I have. Example number, for example, we have independent events already, we've seen it. So I don't think that I need to tell you much about that. Example number 10 I have. A die is tossed. If E is the event, the number appearing is a multiple of 3. F is the event, that number appearing is an even number. Find whether E and F are independent. Question asks, find whether E and F are independent. I taught you 2 events will be independent when I taught you with A and B. You know, A and B are independent when A, P of A intersection B must equal to P of A into P of B. It was a good formula, we already have seen it. 2 events will be independent when this will happen. So you should know here the questions for E and F. Question says given A is a event. A die is tossed. First I'll start. A die is tossed. One should know S will be 1, 2, 3, 4, 5 and 6. This is very simple. One should understand in single instant. N of S equal to 6. Now E. What E says? The number appearing is multiple of 3. Multiple of 3. What E contains? What E contains? Multiple of 3, 3 and 6. And F is number of element, you know, 2. Without writing it, we can understand it. F is, the number is even. Number is even. So what F contain 2, 4 and 6 even number. Now, you know it what I am going to do. First of all, we want to show E and F are, whether E and F are independent. So what to show? We will show E intersection F should equal to E into F. If this will follow, events will be independent. So one by one I will find all. Look at, I tell you how we can find. How we can find. N of E 2. So P of E will be N of E upon N of S 2 by 6. Meaning 1 by 3. What about this? N of F will be 3. P of F will be 3 by 6, 1 by 2. And P of E into P of F will be 1 by 3 into 1 by 2 equal to 1 by 6. Confused? Please don't, because finally what we want to show, P of E intersection F should equal to P of A into P of E into P of F. So P of E into P of F already have got it. Now one thing is remaining, P of E intersection F. Now, what is E intersection F? Can you think? E intersection F. So what is common element? 3, 6, 2, 4, 6, only 6. How many element containing in this? 1. So probability of E intersection will be N of this upon N of S. S was 6. So 1 by 6. What you have got? Very interesting, na? P of E into P of F, we got 1 by 6. P of E intersection, we got a 1 by 6. Since P of E intersection F answer, P of E into P of F answer, both are equal, meaning E and F are none else but they are independent event. So whenever you need to show E and F or any two events are independent, you have to show this equal to this, so that one by one do all the procedure. First I got N of E, then I got P of E, then I got N of F, P of F, I multiplied and I got a side P of E into P of F. Then I got E intersection F, number of element, probability, and saw that both are equal, meaning events are independent. That's simple. So okay, hope you have got it. How we can show that events are independent. Now look at questions are almost same. Example 11 and 12 are same based on that one. The last thing I'm telling you, example number 14 looks very important. Very important it is. When A and B are independent, the probability of occurrences one of the events A and B is given by 1 minus P of not A, P of not B. Now it looks tough. You can understand that without looking in a book. I have written whole the question because very specific it is. I can tell you. First of all, I want to pull your attention towards the language. A and B are independent event. First thing. Second, probability of occurrences of one of the events A and B. So I tell you that in class 11th you have studied that one of the event, meaning A union B, that's many languages it is containing. One of the event of A and B, one can say at least one event. At least, very important word it is. At least one event A or B, always follow this language. And this you will write in class 11th. P of A union B. You know the formula. You know the formula. P of A into P of B, P of A plus P of B minus P of A intersection B. This is not the new formula, guys. You already have seen it. This time we are doing very same. And let me explain that. The answer is given that probability of occurrences of one of the event A and B, it means that P of A union B, which should be equal to this one. This is to prove. I can show here. Look at. Very simple thing. First I tell you that what is a P of A union B. Because you are told here for probability of occurrences of one of the event A and B, meaning P of A union B, we want to find out. So instead of occurrences, at least one event may come, at least one. So P of A union B, which we know P of A into plus P of B minus P of A intersection B. Now very interesting, I'm writing here A and B are what event? Independent event. And you know, when A and B are given, they are independent. One should know that A intersection B is equal to P of A into P of B. We already have seen in initial part of the lecture that P of A intersection B is equal to P of A into P of B when A and B are independent. What will happen? A union B is equal to P of A plus P of B minus this will happen P of A into P of B. Now what will come? Look at properly. A union B is equal to P of A. I will take out P of B common. What will come? 1 minus P of A. You should know P of A plus P of B. 1 minus P of A, it means P of not A. You know it. P of A plus P of B into P of 1 minus P of A, meaning P of not A. Already you know from 10 class you have been studying that one. Again, P of A I am writing 1 minus P of not A plus P of B into P of not A. This I have written 1 minus P of not A. Now look at 1 minus, take out P of not A common. What will remain here? 1 minus P of B, and you know it. 1 minus P of not A, 1 minus P of B is P of not B. That formula you have got, very, very important formula you have got. This is a language we'll use, that probability of either A or B, at least one of them, or one of the events A and B. Many language can be used. The formula is 1 minus P of not A into P of not B only when A and B are independent. When A and B are independent and question asks at least one of the event, or A union B, or A or B, or one of the event A and B, we have to follow the formula. But please keep remember, this formula is only applicable when A and B are independent event. So hope you have got it. Now the question is yet to tell you. I will tell you definitely that when this formula will be used in the question of the exercise. Thank you. In next lecture we will study that.